So yeah, this session, I think it was originally triggered by a issue and discussion about how are we going to put observability in Node.js, and specifically because the emerging standard, de facto standard in the industry, which was the OpenTelemetry, and it's also incubated in the CNCF project, which is part of the Linux Foundation. And yeah, so before we are getting started on the detailed discussion, I think I'm going to have a very quick look on how the OpenTelemetry project operates and how people collaborate on the OpenTelemetry project, because it's also an open source project, just like Node.js. So starting, so for the whole slides, I'm going to put my OpenTelemetry maintainer hats on, and yeah. So the OpenTelemetry was started in 2019 as a merge of the Open Tracing and Open Sensors projects, and to create a coherent standard for both tracing and metrics. And afterwards, we added like logging and like profiling, but there are some works going on to standardize like profiling. So OpenTelemetry now has emerged as a CNCF most active, the second most active project just after Kubernetes. So from the data that we can find on the CNCF project list, that we can find that OpenTelemetry and Kubernetes were the two of the most active projects in the CNCF workspace. So it has been adopted by many vendors, observability vendors, and some people might call it as a de facto standard because of the adoption rate. So inside the OpenTelemetry, we code that there are three pillars of observability: and traces, metrics, and logs. In traces and metrics are the two most outstanding API in OpenTelemetry, because that's the two API set that OpenTelemetry exposes directly for users to adopt. And the logs in the OpenTelemetry is designed to step away from the formatting and how people like usually directly log APIs. So OpenTelemetry in this case will only act as a transportation for the log formats, and more focused on the events that are like on the structure that's more similar to a log, and they are going to be transported and associated with like traces and metrics in that case for observability. And people are still working on standardizing the profiles inside the OpenTelemetry project, so that we can have a unified profile format across different language runtimes. So that will be probably coming in the soon future. So I think inside the Node.js, when we are talking about improving the observability support, we are probably going to focus on the traces and metrics, because that's the user API that we will directly involve on top of the Node.js building APIs. So when we talk about OpenTelemetry, it's inevitable that we have to talk about vendors. So what are vendors exactly inside of in the context of like cloud native computation? In the OpenTelemetry context, we would code that where you store your data and where you pay and who you pay them to store your data to be the vendors. And OpenTelemetry is never intended to be like storing your data or like visualize your data. OpenTelemetry is only intended to be the API layer for people to decouple from a specific backend vendors, so that they can own their data. So that's a design principle that inside the OpenTelemetry API, users are the owners of the API. Users have to be able to define the API, how to be interpreted by these backend vendors. And OpenTelemetry's scope is strictly deliberately designed to leave the backend and visualization to the backend vendors. After all, the OpenTelemetry is a collaboration between all of these vendors. So that's the distinguishment between the OpenTelemetry and the various vendors. And how does OpenTelemetry works to decouple the users and the libraries, specifically the instrumentations from the backend vendors, is that OpenTelemetry intentionally split the API and the SDKs into two components. So users and libraries will instrument their code and their applications with OpenTelemetry API, and OpenTelemetry API will be a no-op layer by default. So if you didn't install any SDKs or vendor exporters, the OpenTelemetry API will just be a no-op layer, and it does nothing, and there's no performance cost. Well, hopefully. So even there's a performance cost, it should be minimum as possible, so that the apps and libraries will be instrumenting their code with the API only, and whatever the user wants to export their data to, they will plug in their SDK into the OpenTelemetry API and then transport all the data to whatever backend you would like to transfer to. And that's kind of like how OpenTelemetry is designed to be like. And OpenTelemetry also designed a web protocol for all the backends to consume the data if they don't provide any like explorer implementations, so that this OpenTelemetry protocol is designed to be transmittable on a binary format. It does provide like gRPC transport, or preferably if people want to be more broader compatibility on the current internet, they can also transport the protobuf on the HTTP protocol, so that they are not limited to like have to transport on gRPC. The OTLP is now currently supported by every observability vendors. They can directly consume the OTLP data and providing the OTLP backpoints. So virtually, I think nowadays we can use OpenTelemetry APIs and the official SDK without installing virtually any backend SDKs specifically to do the observability things, so that it gives user the full flexibility, but it's also up to user choice if they want to use the backend SDK for more feature-rich feature-rich support. And there's also another important part in OpenTelemetry effort is that people are standardizing these semantic conventions inside the observability world. The reason that the semantic conventions matters is that if we like say going to create a span and attach like HTTP response status code to the span, traditionally we can name the attribute like this span attribute as HTTP code or HTTP status or anything that could be specific to a backend, but OpenTelemetry is going to specify that inside the OpenTelemetry officially authored instrumentations, we are going to say the HTTP response status code will be the unified attribute, semantic attribute for every instrumentations, and then the backend will have a unified attribute name and values to be equally interpretable across all vendors. So a user do not have to code their span attribute names or metric attribute names according to a specific backend. So in that case, they will gain more flexibility on their choice of different data backend. So the OpenTelemetry project is also hosted on GitHub, and there's a GitHub org called OpenTelemetry, and there is a central part of the project is called specification. It defines the data flow and the semantics of like what does starting a span do, or what does a counter do across different languages. So the specification is not bound to a single language. It does not specify the detailed language interfaces, but it defines the data flow so that the data produced by OpenTelemetry SDKs and APIs will be equally consumable and equally interpretable by different vendors, because the data flow is defined by the OpenTelemetry specification, and you can assume that how the data is being produced and if the data can be modified later or something like that. And then there comes like per language APIs and SDKs for their own repo. And there are also like auto instrumentations that people don't have to, application authors do not have to instrument third-party libraries. The auto instrumentation will provide zero code observability into these third-party libraries. Of course, this is language specific. And then the fourth one is the collector, so that if you do not want your application to talk to the vendor backends directly, you can use OpenTelemetry collector to help you to proxy the data, and the collector can transmit the data into different backends for different signals. So you will only, so the application will only connect to one single collector, and the collector will, like say, for traces, I want to transmit to Jaeger, and for metrics, I want to transfer to Prometheus for data storage. So still, the collector does not provide any data storage. It's also up for the application to decide where they want to store the data. OpenTelemetry will leave the scope of the data storage and the visualization to the vendors. And also the semantic conventions specifically for specifying how the attributes and the spans, what does this means. And finally, the OpenTelemetry protocol, which defines the OTLP protocol data structure. And yeah, lastly, it's about the project governance. It's apparently a big project. We can see that it's the second largest, most active project in the CNCF. So it's not a like small project. So there are people who governs the project scope and governs the technical directions of the OpenTelemetry. And similarly to Node.js, we have some rules on TSC that we cannot have more than a certain level of TSC members from the same employer. The same rules applies in the OpenTelemetry that so that the OpenTelemetry will not be dictated by a single data backend, and so that all the backend will be benefit from the OpenTelemetry project equally and balanced. And the governance committee of the OpenTelemetry is elected regularly. So you can see that from the list, there are very diverse employers of the technical committee and the governance committee of the OpenTelemetry project. And now let's take a look on OpenTelemetry JavaScript specifically. And the OpenTelemetry OTLP data, as we mentioned earlier, it has been adopted by majority of the data backends. And we can take a look at the OpenTelemetry official website. You can see that the native OTLP means that if this specific vendor support the native OTLP endpoint, and so that you can use pure OpenTelemetry open source SDKs and APIs to transmit data to this specific backend without their proprietary SDKs. So you can see that it's being adopted by the majority of the vendors. And the OpenTelemetry API and SDKs, they are the data front end, which means we do not provide any data storage. And it has been emerged as the most significant client for producing, I'm saying specifically for producing the trace and metrics data, because OpenTelemetry, the design of the OpenTelemetry structure allows the vendors to to plug their SDKs inside the OpenTelemetry API, which means they can consume the data directly from the OpenTelemetry API as well. So we are specifically to see how many people are using the OpenTelemetry as the data front end to produce the data. So according to the NPM states, I just grabbed these states yesterday, and we can see that the OpenTelemetry tracing, the OpenTelemetry API is, the download size is like 40 millions per week. And if we are going to take a look at the SDKs, the adoption rate is going to be pretty much higher. Traces, because traces was stabilized earlier than metrics, so the adoption rate was even higher than metrics. And I distinguished from vendors from adopting OpenTelemetry APIs plus SDKs between the vendors only adopted the OpenTelemetry APIs to consume the data. So if the traces, the 90% of the traces adoption is only counted the vendors that fully adopted the OpenTelemetry API and SDK. So that's 90%. But if we count vendors with OpenTelemetry APIs as well, the adoption rate will rise to 99% for traces. So it's almost the whole ecosystem is adopting the OpenTelemetry for traces. And for metrics, if we only count vendors with OpenTelemetry APIs and SDKs, they are about 60. So it'll be like hotel exporter plus these hotel vendors. There'll be about 66%. But if we count in the vendors adopting OpenTelemetry APIs as well, the adoption rate will rise to 80%. So the adoption rate, I can fairly say that it's significant. So that comes to a question on how we can improve the OpenTelemetry support in Node.js without like creating disparities between the ecosystem, like creating new standard for people to adopt. I think the path forward is that given that OpenTelemetry has already split the API layer between the SDK layer, so and I specifically listed that between the vendors adopted OpenTelemetry API plus SDK and OpenTelemetry they only adopted OpenTelemetry API. The one way that could benefit all OpenTelemetry vendors is that if we could adopt the OpenTelemetry API only, that's a thin layer, and it's now by default, and vendors could plug in their SDKs anyway, and they can do with the current npm package, which is done by a global state, and it's called some global this symbol OpenTelemetry.js.api.1, which is the similar approach that we did in Undici for the Undici dispatcher. So it's similar to OpenTelemetry that this global this state is a global dispatcher to dispatch the API operations in the OpenTelemetry API npm package to the installed OpenTelemetry SDK packages. So this maintains the compatibility between the current OpenTelemetry API adoptions, and it will allow people to provide to have building OpenTelemetry support if that. And notably, OpenTelemetry is not bound to a specific implementation. So it's a open source project. So we are definitely welcome performance improvements or any proposals that could improve OpenTelemetry as a whole that benefit all vendors. So yeah. So that comes to another topic that we have the diagnostic channels, which is awesome in Node.js for people to instrument their code as well. But specifically, OpenTelemetry is not a replacement for diagnostic channels, because diagnostic channel is designed to be a more generic diagnostic messages. You can, arbitrary data inside it, but the OpenTelemetry is designed to be more constrained and a more interpretable data, like specific for traces and metrics, for people to directly this observability data that could be transmitted to the backend. So right now, OpenTelemetry official instrumentations are based on monkey patching, which could be, I would be, frankly speaking, it's not very good. So we are also exploring adopting diagnostic channels to improve the instrumentations inside OpenTelemetry as well. And there is also a fancy project. It's called Node.js, and thanks to Brian for contributing it to the Node.js project recently. Was it recently? Probably months ago.
It's like half this room.
Okay.
Not even just Datadog, like a bunch of other folks have been working on this.
So the Node.js I think can provide either build time or runtime instrumentation via the code transformation. So here comes to the distinguishment between these three approaches. The diagnostic channel definitely needs the library authors to explicitly say, hey, I'm going to instrument my own code with the diagnostic channels. And the Oxygen and monkey patching approaches were designed to be that even if the library authors does not provide building diagnostic messages for the for OpenTelemetry to instrument, we can transform their code or monkey patch their API codes to emit the data to be consumable by the data backends. So I think, OpenTelemetry is a open source project and the second most active open source project inside the censorship space. So we are definitely welcome ideas and contributions to the OpenTelemetry to improve, to benefit everyone, I would say, because users are definitely going to be benefited from the OpenTelemetry project, and data vendors will also be benefited from all of these collaborated instrumentations as well. So yeah, I think I'll leave the rest of the time for open discussions and questions.
You go maybe. Then
I got nothing to say. Go for it.
okay. I have a question that is. Hi, I have a question that is maybe a little bit provocative. Okay, so sorry for poking, and it does not. I don't want to put anybody on the spot. I just want to state why people are looking at alternatives to the. By the way, first of all, the OpenTelemetry standard is great. Okay, the spec is phenomenal. It's fantastic. Okay, I don't have much problems with at OpenTelemetry/API. Okay, my biggest concerns is with the current Node SDK that is adds significant amount of overhead. Even way more, like it even as some very trivial performance fixes that could be done implemented in it that I've never, like it seems from the look of it that performance has never been a key driver of that repo generically. Okay, like to be clear, this happened last week, so I'm referring to last week. I had a customer saying, "Oh no, we have to pull this, like it's too heavy." Okay, like it's and to be, I'm making it very like this is a problem that I'm seeing on both sides. Okay, and as Node.js, I think we should try to provide. And I'm somewhat not sure that the classes in that repo provide that. Okay, at this point, like this is sorry to put the problem. I don't know if others have to, and I this is with utter respect. Like I use the API module a lot. I use the tracer. I use all of those observability products. Okay, so. Yeah. I'm familiar with the topic. So
yeah, I think I can quickly respond to that. So the OpenTelemetry official Node SDK is a combination of the API, traces SDK, metrics SDK, and all the commonly used instrumentations which are implemented with monkey patching. So yeah, if we like say it was originally designed for user experience, like you don't have to say install every supported instrumentations by hand. And if you install this one single npm package, it will bring in all the instrumentations and automatically generate the data, which may be nice. But like you said, it also brings in a lot of dependencies, like all these instrumentation packages for the libraries that you may not use. But if we say, I'm only going to use the OpenTelemetry API and traces SDK and metrics SDK and only install the instrumentations for libraries that I actually use, the cost could be reduced a lot and the library size could also be reduced a lot. I think that's why I feel like there are definitely rooms for collaboration between the Node.js project and the OpenTelemetry, like on this page, like diagnose channels, orchestrons to improve how we are going to instrument these third-party libraries.
It's not just the instrumentations, okay?
Yeah.
Like I did a very quick search, okay, of something that I look for when doing performance review of code, okay? I did it in 1 second now, but there are probably an handful of those things, okay? They're just looking for a dot for each, in the code, it is showed like 117 instance of for each. Well, I think it's probably known by everybody in this room that just a for loop, you see, it's order of magnitude faster at least compared to a for each. And it's also sitting in some clear hot path of the library. So when I'm saying has not been designed or performance is not being taken as a first class concern of that implementation, I like it. And my experience come from looking at flame graphs and say, oh, this is the problem. Okay, so it's literally. And a lot of them are not even on the SDK instrumentation part. It's really like in basic things like the record function. Like the one last week was on the metrics side. Like it wasn't, and it was not like sometimes is in a lot of cases it's trivial. It's literally small things, but it does not seem that there is an attention to. Improve, lower the overhead of those things. Okay, it's more an attention of compatibility and getting everything on board, which I support. But as a lot of enterprises want to run these things, and then you show, oh, this is I enable on off, and there is a significant gap between the two. It's a problem for those companies.
Yeah, I would agree that if there are already analysis done, that will be definitely valuable to be reported to OpenTelemetry issue tracker, so that it's an open source project. So definitely we need people to report this performance bottleneck back, and they can be checked. Yeah, thank you very much.
I'm doing it now.
Thanks for doing it now, Matteo. Just to sort of echo the points that you're making, OpenTelemetry is just like Node. It's a very open project with very open collaboration. So we should all feel comfortable, whether it's us APM vendors or Matteo running a tool or whatever the heck he's doing over there. We should all feel comfortable to make the contributions and open the issues and whatever when it comes to OpenTelemetry. It's just as open as anything else. That said, I did open a fun PR on Node. I think a lot of the things you were talking about were in reference to that PR to add some level of OpenTelemetry support to Node. I think it's worth talking about the motivations behind that. The primary motivation, let's be honest, the primary motivation is so that people can have some nice out-of-the-box experience with Node, providing observability without having to install any of our various vendor tools. I'm pointing this way because there's a lot of APM people in this corner. But like without having to install any of our tools, providing some data out of the box is a very nice thing feature-wise, both for us and for users of Node, right? So that is the primary motivation. On top of that, there's also the ability when things are built into Node.js core, there's this interesting opportunity we have to optimize them in ways that could not be done in userland, or they would be more difficult in userland. Right, so it's not just like necessarily the quality of the code. It's not necessarily just like the .for eaches and stuff like that. But like we could re-implement things in native code or all kinds of things like that, and which could give us performance benefits. And this is the kind of stuff that makes a lot of sense to do there. And sort of on top of that, the more stuff that's built in, specifically with observability, the less needs to be shipped by APM vendors, which is exceptionally useful in things like serverless environments where people really care about what's the package sizes and whatnot. So those are sort of the set of motivations. Does that make sense?
Can you clarify what specific optimizations that we cannot do at userland for OpenTelemetry specifically?
Well, in most cases, you certainly can do things in userland, but if for example, we're talking about optimizations that would be done in native code, it's a whole lot easier to do that in Node.js core because then you don't have to distribute it separately. Right.
And can you repeat that the data code?
Sorry, if something is built into Node.js core when it comes to native code.
Native code.
Yes. Then it's a whole lot easier to deal with. Like we don't have to deal with the distribution problems around dealing with native code.
Yeah.
Right. Sure. So if we're talking about that kind of optimization, even if it were in OpenTelemetry, it would be much more difficult to do outside of Node.js Core. We had talked about that a bunch of months ago. So like, yeah, does that make sense?
Yeah.
Okay. And then the other thing I wanted to say about the PR itself is like, it doesn't really expose anything in terms of something that OpenTelemetry/API can connect to, but that's certainly something we can easily do, right? Because it's just a matter of implementing the internals underneath. Now there's a lot of, I'm saying easily, that's a lot of hand waving there, of course. But like we've done it, like at Datadog, we've done a similar thing with that for our tracing library, implement tracer providers, so we have the ability for OpenTelemetry/API to connect to that, right?
Yeah.
So and other vendors have done the same. So the theory here is that if we want to go beyond just purely automatic auto instrumentation, if you will, and move into more API support, that should be a doable thing with, you know, whatever I've done in my PR or an alternative implementation as the foundation for that.
Yeah, I think it's definitely worth exploring, but like I said, OpenTelemetry was established as a vendor neutral and as a part of the principle. So we would definitely want to see how we can improve the performance without like hurting part of the vendors. So like it should be benefited to every vendors, not just a small group. So that's, I think, it's definitely what we are welcomed to explore.
I mean, that sounds great.
Yeah. So the OpenTelemetry API and diagnostics channel, yeah, they are mutually separate. Like they're separate concepts. And I should say, diagnostics channel was actually explicitly created because of OpenTelemetry API. It was intended to serve as a layer beneath it, specifically because going a bit into the history of it, at the time that I created diagnostics channel, there was other discussions about bringing OpenTelemetry API into core, and they were, I'll say, a lot less friendly than the current ones are. It was a less mature project at the time. There was a lot of people very concerned about the implications of bringing that into core, but the capability that it provides is useful. The full surface area of what existed, it was very much up for debate if it was a good idea to bring that in. So I created diagnostics channel as a thing that provides the lower level infrastructure to be able to build something like OpenTelemetry API on top of. And part of the reason why it's shaped somewhat differently is like it's been my experience, and like I've discussed this with most every other vendor, that OpenTelemetry API is a good user-facing API. It is good for just some random developer to add custom instrumentation to their application. It is less good for implementers, for the people building the languages themselves or the libraries. Like it's okay for like directly instrumenting libraries. Some like Next.js are doing that, but it's more geared toward the people that don't understand what you can do with the underlying data model, and so want a very strict, just simple expression that they don't have to think too much about what's happening with the data. It's just, oh, I have a span, the span goes somewhere. But as an implementer of these systems, like we understand there's a lot more that can be done with the underlying data that can provide very useful expressions of that data, which unfortunately OpenTelemetry encodes various things that prevent us from being able to do that usefully. A good example is like streaming. There's not really a great way to do that because they just give you, oh, here's a huge blob of OTLP. Well, you've encoded like the entire trace into one big blob. Like maybe you can pull like some of the spans up, but it like you can't do like, oh yeah, I received my span start, I'm just gonna like stream out the start of this, and I'm not even done the span yet. Like I used to work on a product that like would actually stream out everything as individual events. So you could see a span visualized in the UI while it was still happening. And that's extremely useful, and OpenTelemetry can't do it. There's a lot of these cases where OpenTelemetry, like it is great that there is a tool that is becoming widely adopted, and like it exists out there. It's very useful for everyone to be able to get this, like get the more data than the none that they had before. But it imposes a bunch of things which I think it's useful to avoid those parts.
I think a quick reply to the streaming part is that the API does allow streaming. The API does not persist any data in the language. But I think you're specifically talking about OTLP, the data protocol. That the data protocol does need that, for example, a span to be finished to be exported in this specific case. So I think definitely we can do like streaming implementation or streaming SDK inside the OpenTelemetry API, and we can export a like a streamed format of the data. And I think this is definitely worth bringing up to the data protocol working group inside the OpenTelemetry.
So there's
this is not specific to JavaScript, I would say.
Yeah, it's not. There's a bunch of these things like that. Like OpenTelemetry is essentially a collection of a bunch of what should be loosely connected specifications, but are not being presented or considered in that way. So it like having talked to mostly every observability vendor, all of them are under the impression that it is expected that they export OTLP. Well, that doesn't necessarily make sense in a lot of cases. It is expected that they have this particular API. It is expected that they have exporters. It is expected that they have span processors. These are individually useful components, which in some vendors might make sense, in other vendors might not make sense. And like there's the system just simply is not very composable, basically.
Well, I mean, OpenTelemetry is a collaboration of vendors. So if there are some like feature requests to the OpenTelemetry, it's definitely going to be worth to be brought up to the OpenTelemetry to improve it, because that's going to be benefit all the vendors.
Like there's a lot of vendors that are involved, but like most every vendor I've seen. So you showed the like vendor, like the list of vendors that have adopted it earlier, and like while that is useful, like all of those vendors support receiving OTLP. Almost none of those have that as the default. That is not what they want their users to be using. That is what they reluctantly accept. Like ingesting that because everyone is expecting this of them. There's actually relatively few of those vendors that are happy with where it is. Part of that
every
is
vendor is not happy with OTLP. They should probably this is a group of vendors inside of OpenTelemetry. They should make OTLP better.
It's complicated. So a big part of that is these vendors want to make money, and to make money, they need to have things that differentiate themselves. And so they don't want the things to exist in OpenTelemetry necessarily, which results in you have this specification that most of the vendors actually kind of don't actually contribute to that much. They just sort of sit there and say like, oh, we'll just make it minimally useful to satisfy the end users, not the implementers.
Yeah, I think that's what I am insisting the whole way, that even if we are going to contribute to Node.js for the improving the observability, we should not prefer certain vendors. This must be done in a standard way for Node.js to be an open project.
A bunch of other people.
I have no idea if this is working. Okay. On the streaming point, I think this goes back to that if we provide the API, just focus on the API. If we provide the API in the runtime, we have lots of opportunities to implement optimizations. In workers, we have streaming, what we call streaming tail workers, where it's that stream of events that come out. You know, a request started. You know, here's a span start. Here's an attribute, and you know, all the way down to the span is closed, the request is closed. That comes out as a stream of events. That gets sent to a collector that produces the OTel view of it. That this is a completed view and gets forwarded on OTLP. From an API perspective, though, from what the users are going to see ultimately when we do provide a user-facing trace, is going to be an API very similar to this. To where, you know, I don't think we've decided if it's going to be exactly the OTel API or not, but we'll figure it out. But by providing the implementation of the API and not necessarily taking the implementation of the API from the ecosystem, we can optimize this and we can change the way that this works. And Node does not necessarily have to publish a composed OTel span. It can see, here is a stream of events. Whoever's listening to this composes that into the final result. And if we went with that approach, we could have kind of the best of both. We have the standard API that everyone's using, and we have an optimized data flow on the back end that we can consume any way we want. So I think I would rather us not get too hung up on the details of what the OTel SDK does, or how that project actually composes everything together, and instead focus on what are the specific needs of this API in Node, and do we implement this natively in an optimized way?
I'm tired. I don't.
But part of the reason for diagnostic channel being designed the way it is to be just a generic event stream, so that we can layer APIs on top of it or on the opposite end of that. So like the intent is like OpenTelemetry API could just sit on top of that, publish to channels, and who cares what happens in the background. That could feed into another OTLP thing somewhere if that is the export that you want. If you want a different thing, you can do a different thing. That is why diagnostic channel is this specific way.
Yeah, I think OpenTelemetry is also exploring different ways of how we could implement the API package as well. Like, we can adopt diagnostic channels to improve the performance when it's just a no-op. I think the reason that we are doing slow here is specifically that the API package is the compatibility layer, and it has a global state so that different vendors can be compatible with a single version of the API package. We are definitely open to different approaches, like, for example, adopting diagnostic channels, but that could be a major version of the API. And we are cautious about bumping the major version of the API at the moment, because we want to gather more feedbacks around the design. And is Mark going to say something about this?
I was just waiting until you are finished, but I just wanted to say that especially this streaming approach is also what one of the other maintainers on Node.js also somewhat proposed right now. It's for API 2.0, as Sheng Tsung said, to have a sort of an events-based API where people could then, if they implement an SDK, which would then, if an SDK is shipped through Node.js core, also be implemented by that. It really just publishes events. And then whatever implementation is in the background just picks these up and does whatever it needs with them. Reference implementation would probably still like work as the spec intents, but it kind of opens up a lot of options there, which could be helpful.
Yeah.
James?
5 minutes, I think, maybe a couple more questions.
Yeah.
James on the Zoom is raising their hand.
Yeah, so I have at least one question that, if I can get an answer to it, may help me understand this conversation better. On slide 12, are you trying to suggest that these are replacements for OpenTelemetry?
No, I'm specifically saying that OpenTelemetry can build on top of either these three approaches, as long as it can, like say, OpenTelemetry is not a replacement for diagnosis channel. It can adopt either of these for better instrumentation.
Correct. Okay. And I think everything that Stephen has said is what I agree with. Yeah, there we go. Thank you.
Yeah, so maybe one last question here. It's like OpenTelemetry provides the specs and the official SDKs, but this is not guarantee for like the correct behavior. So a vendor could maybe alter the data or override the data, and patch that package and so on. As a customer, is there a way to know or to verify that that vendor is respecting the specs? Maybe something like a conformance test, like a WPT, such as we have on the JavaScript runtime, or just, okay, we can trust this, the OpenTelemetry website, and whenever we found out, okay, this vendor is respecting, his name is on that list, so I can go with him.
I think there's no currently officially maintained test suite for different vendors inside of OpenTelemetry space. There's only a API contract that's established by the OpenTelemetry API package that you cannot do arbitrary things beyond the API scopes. Maybe other vendors could weigh in to see if you have some specific test suite that we could share for the overall benefits.
But we still agree that the vendor can maybe add another field to the objects, do same changes on the protocol, and you have like the freedom to change whatever you want. Okay.
Sorry, I wasn't sure. Was the thing finished now, or?
Yeah, you can.
Oh, okay. Just wanted to make sure everything was said already. I just wanted to touch a little bit on the current PR that's open and some of the motivations behind that. Circling back to the beginning, I do agree that there's a lot of optimizations that can be made, and that the size of like specifically the OpenTelemetry SDK node package is humongous. So I definitely share the concerns there. What I wanted to add to that is that size and performance are becoming a bigger concern for us, especially in Node.js. So that is something that we are actively looking into and trying to improve at the moment. Especially around OTRP serialization is one of the first things that we were looking into, but also there's smaller efforts in making smaller improvements across the SDKs. So once that is out of the way, we hope to be able to deliver a better experience for people in that sense. And the one thing that then kind of sticks out still is simplifying the setup. Which I don't think we have a lot that addresses this at the moment. There is some effort in providing declarative config, we call it, which is essentially you give it a config file, configures everything for you, and it just sends it there. So the idea is that the vendor can tell you, this is the file that we want you to use to configure everything, and it just works out of the box. That, of course, is very difficult to reconcile with the need for smaller SDK, which is where there's some friction points. In general, I think it's not completely unrealistic of the OpenTelemetry organization to define a defaults thing or like a minimal distribution of OpenTelemetry to address some of these concerns. So a little bit of rambling there, but that's just my view as an OpenTelemetry JS maintainer on that whole topic. So just wanted to bring that up. So not really a question, but just some statements.
Yeah, just to respond to that specifically, the defaults thing is something I've brought up before, that like OpenTelemetry was largely defined in an era before OpenTelemetry became the default. And so it has a huge toolbox of things that mostly are not used. Like mostly everyone is normalized on the like W3C propagation, but there's like a dozen possibilities. There's a whole bunch of different samplers, all these different things that just having reasonable defaults would make things a lot easier for a lot of people.
Yeah, I agree. One of the things that is kind of difficult to get on the road is like getting everybody on the same page what the proper defaults should be. And I think that's also something that when building something into the Node.js core area is something that people might run into, where people say like, hey, I need this extra stuff or need this extra propagator and need to interact with that somehow. Because one of the main concerns that I have seen on that PR is also like, how do I link my spans with the ones that the internal thing is doing? And then also one of the things that we were running into in Dynatrace is also we have the old agent, right? And then there's OTel. And oftentimes these two things, they don't play well with each other. So there's also another risk of when we say we simplify the setup and we make everything easier, we introduce that same friction point again. And then in the end, it could be that it's a bit difficult to understand for users what they should use now. Yeah, there's, I would say for especially the defaults thing, this would definitely be something to raise with the specification SIG. The specification SIG is like essentially the technical committee are the maintainers of that. And they have a lot of insights into what's going on at vendors and stuff like that, and would probably work through something, a proposal like that, which we would then implement as the Node.js SIG.
Any other comments? No. So yeah, let's wrap it up. We ran over about 5 minutes in the afternoon session, the first part. So we are going to have 10 minutes break.
We have quite a long buffer later. I think we can take 15, right? Should we come back at 5 past? We've got a buffer slot afterwards.
No, that's for the. That's for the new sessions, so we can still reconvene in 10 minutes to continue as scheduled. I think there are not afternoon snacks, right? So in the same place as the lunch. So please enjoy, and we will reconvene in 10 minutes.